In this video, we're going to review some common ratio problems that a student might see in algebra class. First, we are presented with this problem. Jimmy can run 3.5 miles in 20 minutes. How far can he run in 1 hour and 10 minutes? Folks, one of the keys to solving word problems is to look for expressions like this. How far? How many? How much? Whenever you see words like that, that's what you're going to set your x equal to. All right, so when they ask you how far, we know immediately that we're going to set x equal to a distance unit. And the only distance unit here is miles. So we know x is going to be miles. The next step in solving these types of problems is to create ratios. And we're going to do two parts. We're going to do a part 1 and a part 2. Part 1 is going to be a ratio or a fraction using the information they give us, and part 2 is going to be a fraction that we create based on what they're looking for. So here in part 1, they tell us he runs 3.5 miles in 20 minutes. That word in means fraction line. Another word that means fraction line is per. $12 per hour. 3.5 miles in 20 minutes. Whenever you see in, whenever you say per, or another one is for every, all of those words or expressions mean fraction line. Okay, so here it is, 3.5 miles in, that's the fraction line, 20 minutes. Okay, this should be miles on top, not minutes, sorry. Okay, whenever you set up these ratios, it always works out better if you put time in the denominator. Okay, now let's go to part 2. We know that they want us to find the number of miles. In part 1, our ratio has miles in the numerator, so we know that this is going to go here in part 2, x miles. Okay, the only thing we need to do now is finish composing the part 2 ratio. So let's go back to the problem and see what they want. How far can he run in, there's your fraction line, 1 hour and 10 minutes. Okay, so this is going to be 1 hour and 10 minutes. Now, folks, we have a problem. These units have to match. Miles and miles matches in the numerator. However, we have minutes here and hours and minutes here. Excuse me. So we need to change this denominator to minutes. We know that 1 hour is 60 minutes, so 60 minutes plus 10 minutes is 70 minutes. Okay. Once you have your ratio set up like this and the units match, you are in the driver's seat. We are simply going to cross multiply. We're going to do 3.5 times 70 equals 20 times x. Now, once you have your units set up in your ratios, in your part 1 and part 2, you don't need to bring the units down into this equation. So we're simply going to multiply 3.5 times 70, that's 245 equals 20x. We're going to divide both sides by 20. 20 over 20 is 1. And 245 divided by 20 is 12.25. Now, folks, I'll show you a quick shortcut on your calculator. This is the only problem I'm going to solve like this. To do it on a calculator, you punch in 3.5 times 70 divided by 20. And that'll give you the x. The calculator figures out PEMDAS for you. This times that divided by that. In our next problem, we're given that Paul needs 3/4 cups of sugar to bake one batch. How many batches can he bake with 12 cups of sugar? First thing, how many? That jumps right out at me. Whenever you see words like that, whatever follows is your x. So we know x is going to equal batches. How many batches. Okay, we're going to use the information they gave us to create part 1. Then we're going to create a part 2 that's going to contain this x somewhere, we're not sure where, top or bottom yet, and we're going to use this to solve the problem. Okay, here we go. 3/4 cup of sugar for every 1 batch. We know now that x is going to go on the bottom. And 12 cups up here. Our units match, therefore we can do cross multiplication. All right, so again, the shortcut with the calculator is going to be 12 times 1 divided by 3/4. So 12 times 1 is 12 divided by 3/4. We're going to use keep, change, flip. Keep the 12 over 1. And we're going to reverse, or I should say, change that fraction, flip that fraction, change the multiplication. Okay, now, folks, when you're dealing with this, when you're multiplying fractions, of course you do not need a common denominator. You can multiply straight across. So one way to do this is to multiply and get 48 over 3, and then go about reducing that fraction. But I think this step is wasted. What I would do here is I would bring the factors over as is in their broken down fashion. Okay, and now when I break down this fraction, I'm going to ask myself, are there any 3's hidden in a 12? The answer is yes. You can break down 12 into 4 times 3. All right, there's the original 4, and then there's 3 on the bottom. Now we can cross out the 3's, and you have 4 times 4 equals 16 batches as your final answer. Next, we are told that a car travels 261 kilometers in 2 hours. How far can it travel in 4 hours? Again, how far jumps right off the page. The only distance that's listed in terms of units is kilometers. So we know our x is going to equal kilometers. How many kilometers? Okay, part 1 is going to be what they give us. Part 2 is what we're going to create. We're going to take this x kilometers and put it into part 2. We're not sure where it's going to be. Part 1, 261 kilometers in 2 hours. Remember, time tends to go in the denominator. It makes it easy. And we're going to put k kilometers up here. And how far will it be in 4 hours? Remember, part 2 is the second part of the problem, and that is going to be associated with the x. You're going to do 261 times 4 divided by 2. And when you do that, you're going to get x equals 522 kilometers. And a quick check, does it make sense that in twice the time, it goes twice the distance? And the answer is yes. Next, we have a bag that contains 72 blue marbles for every 9 red. If there is 108 red, how many blue marbles are present? Here it is. How many blue marbles? We're going to set x equal to the number of blue marbles. And we know that's going to go in part 2. Part 1, we're going to use the information they gave us. The bag contains 72 blue for every, in, per. That translates to fraction line. 9 red on the bottom. X blue is going to be on the top. And 108 red. That's part 2 in terms of what they give you. We're going to do 72 times 108 divided by 9, and the answer is going to be 864 blue. Okay, we're going to use the part 1 from the problem we just completed, but there's going to be a different part 2 here. Okay, the bag contains 72 blue for every 9 red. 72 blue 4 every is our fraction line, 9 red. Okay, we forgot to say what x would equal. How many are red? So we're going to set x equal to the number of red. Okay, now, the bag has a total of 9 marbles. Okay, so in part 2, they say 9 total marbles. How many are red? But here's the problem, folks. These units don't match. So we somehow have to get the total marbles involved. We have blue marbles, we have red marbles, and now we have total marbles. So this is what we're going to do. We cannot proceed at this point. What we're going to do is we're going to recognize the fact that this part 1 is packed with information. Not only does it tell us there's 72 blue for every 9 red, but it also tells us that there's 72 blue for every 81 marbles total. Now, where did we get the 81 from? We simply added the 72 and the 9. Now, what else does this tell us? It also tells us that there are 9 red for every 81 total. All right, you're going to see this same concept in a problem with how many boys and girls, the ratio of boys and girls in a classroom. If there's a total of 25 students, how many girls, that type of problem. So you have to recognize that this ratio in part 1 gives us this information as well. So now what we're going to do is we're going to take this bottom fraction here, this ratio here, and we're going to say that for every 81 total, there are 9 red. And we're going to use this setup to answer the question. And what we're going to do is we're going to do 9 times 9 divided by 81. So that's going to be 81 divided by 81. So in this scenario, there would be 1 red marble. Okay, this next problem involves boys and girls in a class. The ratio of boys to girls in a class is 3 to 5. If there are 27 girls in the class, how many total are in the class? So what are we going to set x equal to? We're going to look for words like this. How many, and whatever follows, we're going to set x equal to. So x is going to be the total students. Not the number of boys, not the number of girls, but the total number of students. Okay, in part 1, we're going to take what they gave us. They said the ratio of boys to girls is 3 to 5, which means there's 3 boys for every 5 girls. And we want to set up part 2, and part 2 is going to contain x total. Problem is, we don't have total in part 1. We have to create a different part 1. The whole key, folks, is recognizing that this information also tells us there's 3 boys for every 8 total students, and there's also 5 girls for every 8 total students. How did we get 8? We simply added 3 and 5. Okay, so now we're going to use, let's see, what are they? Oh, 27 girls. Okay, so if there's 27 girls here, x total, we are going to use this ratio here. Okay, we're going to flip the units around so they match. We know that 8 total goes up here for every 5 girls. And we're going to take our calculator and we're going to do 27 times 8 divided by 5. This times that divided by that. And our answer is going to be that x equals a total of 72 students. Next, we are told that a kennel has 35 total dogs, some of which are puppies and some of which are adults. If the ratio of puppies to adults is 1 to 4, how many puppies are there? Okay, first thing, how many? Whatever follows is our x. So x is going to equal the number of puppies. Okay, we're going to take the information they give us. There's 35 total. Okay, now, the ratio of puppies to dogs is 1 to 4. So pups to dogs is 1 to 4, which means there's 1 pup for every 4 adults. That should be, not dogs, they're both dogs, sorry. 1 pup for every 4 adults. Okay, so now this is going to be our part 1. Our part 2 is going to have the X pups in it. We're not sure where it's going to be. So let's look at what this information tells us. This tells us that there's 1 pup for every 5 total. And it also tells us there's 4 adults for every 5 total. Okay. Now, they give us that 35 total. That goes in part 2. X is going to be the number of pups. So which ratio are we going to use here? We're going to use this one. So we're going to put this as 1 pup for 5 total. We're going to use our method where we're going to go 35 times 1 divided by 5, and x is going to equal 7 pups. Okay, so we got a little bit jumbled with part 1 and part 2 here, but the important aspects are, what is our x value, how many, whatever follows, we're going to set x equal to that. Here they're giving us part 2 in the first sentence. Then they're going back and giving us part 1 here. So sometimes they're going to mix the location of part 1 and part 2 within the problem. When you do enough of these, you'll be able to discern that. Again, whenever they give you this ratio, 1 puppy to 4 adults, there's more information in there. Namely, here it is, 1 puppy for every 4 adults. Not only is that true, but it's also true that there's 1 puppy for 5 total dogs, and that there's 4 adult dogs for 5 total. How did we get the 5? We added the 4 and the 1.